evaluate the integral. Integral I is equals to, so the question is what? X by root of x plus 4. X by root of x plus 4, where the value of x is a positive value. So if you try to observe here, this cannot be expressed in the form of f dash of x by f of x into dx. Because if I take the x plus 4 under root which is there as t, derivative of this x will become dx is equals to dt. So here dx will come. So dx is equals to dt. But along with the dx, x has to come here. But in this case, x will not come. So that additional x is there. What has to be done? Now this kind of situation you will try to face whenever the power of x in the denominator and the power of x in the numerator are the same. You can see the power of x in the numerator is 1 and the power of x under root is 1. So in that case, what has to be done? You make the numerator and denominator as the same. Under root denominator value is what? X plus 4. How to get plus 4 there in the numerator? Is it possible? So the best way is you have to add and subtract. Add and I'm writing in short, add and subtract 4 in the numerator. That's the only possibility that you have. So that you can get x plus 4. So what happens? Let us see. X plus 4 minus 4 whole divided by, it is under root x plus 4 into dx. Now if I just try to cancel out this 2, I'll get back the question. So question should not be affected by addition and subtraction of that value. So I'm adding and subtracting. Whenever you have this type of problem, this is the procedure that you need to follow. Getting this one? Even if you have like one more example, I'll try to give x by x plus 2. Even in this case also, you'll be doing the same thing. Or the other way is, suppose you're having x by x plus 2 whole square. Even in that case also, you'll be doing the same thing. Now what I'll try to do is I'll group the first two. And this I'll try to separate that minus 4 well. So how is that? I'm grouping this x plus 4 together. Minus of 4 I'm writing separately, divided by root of x plus 4 times of what? Dx. Now what I'll try to do is I'll try to divide this x plus 4 by root of x plus 4. Minus this 4 is there again, 4 separately I'll try to divide that by root of x plus 4 into what? Into dx. Now because there are two terms, according to the properties of integration, I can apply integration separately for the first term, that is x plus 4 divided by root of x plus 4 into dx. Minus, again you can apply the integral for the second term. It is integral of 4 is a constant, I'll take it outside, 1 by root of x plus 4 into dx. This is how we can separate the integral. But the numerator which is there, this x plus 4 can be written as root of x plus 4 into root of x plus 4 whole divided by, it is root of x plus 4 into dx minus 4 times of, you're having this value to be equals to, it is 1 by root of x plus 4 as it is into dx. But we observe that root of x plus 4 and root of x plus 4 will cancel out. It is integral of root of x plus 4 into dx minus, it is 4 times of integral of 1 by root of x plus 4 into dx. So this is how you can just separate it. Now you can integrate this one or make the substitution for both the cases. Therefore, the substitution is common here. Therefore, put x plus 4 to be equals to t in both the terms. Now let us try to differentiate this one. Derivative of x is dx plus 4 is a constant, derivative will be 0 is equals to dt. For x plus 4 we are taking it as t. If you want, you can even take x plus 4 to be also equals to u. But since for all the problems we are using t, we'll continue with t itself. But here, because both the values are the same, x plus 4 and x plus 4 both are the same only. For both the values, I can take only one t. Right? Suppose if you're having here as x plus 2 and here as x plus 4, then I would have taken one as t, another as, suppose if you had x plus 2, for that I would have taken t, For x plus 4, I would have taken, say, u, or I would have taken this as t1 and t2, or u1 and u2 in that way. Because both the values are the same, I am taking for both one single value t. Getting it? So now if I go back and substitute this value back there in the given integral, I'll be getting integral I to be equals to, I is equals to this root of x plus 4 will become t. Dx will become what? Dx will become dt minus 4 times of, again, integral 1 by root x plus 4. X plus 4 is t into dx. Dx is dt. But root has to be eliminated over here. I can write this root as to the power of half dt minus 4 into integral of this 1 by root represents to the power of half times of dt. I can use the formula. Since I know this formula, integral of x power of n into dx is nothing but x power of n plus 1 by n plus 1 plus the constant c. Therefore, it is t power of half plus 1 divided by half plus 1 minus this 4. It is integral of. But t is in the denominator. I can take this t in the numerator. The moment I take t in the numerator, positive power will become negative power times of dt. So because I'm integrating and I can add the constant of integration as c. Therefore, this t power of half plus 1 will give you 3 by 2 divided by 3 by 2 minus 4 times of. Once again, you can use the same formula whether the power of n is positive, whether this value power which is there is positive or negative. I'll be using the same formula. T power of n value is minus half. So it is n plus 1 divided by n plus 1 plus the constant c. Or further, if you try to simplify this one, 3 by 2, when it comes in the numerator, it becomes 2 by 3. And this value of t that I have taken here is x plus 4. So it becomes x plus 4 to the power of 3 by 2 minus 4. It is t power of 1 minus half will be half only, divided by denominator also 1 minus half will be half only plus c. Or further, if I try to simplify this one, it is 2 by 3 into x plus 4 to the power of 3 by 2 minus 4 into this half in the denominator. When it comes to the numerator, it becomes 2 by 1. And the value of t that we have taken is x plus 4 to the power of half plus c. Or you can write 2 by 3 x plus 4 to the power of 3 by 2 minus 4 times of 2 will give you 8. 8 into x plus 4 to the power of half plus the constant c. So that will be the required solution. So these two examples that I have given you, this you can take it as homework. Follow the same procedure. This one. This you can try as homework. Follow the same procedure what I have shown you. Here we'll be adding 2 and subtracting 2 in both the cases. Here I have added 4 and subtracted 4. In these two problems, we'll be adding 2 and subtracting 2 and follow exactly the same procedure. And try to see what's the solution we'll be getting there.